Hey guys, you ready to do some math? Yeah, all right. So we got 10.3 part one right here. All right. Now remember, we've been doing the packet the last couple weeks. Okay. 10.3 is going to be straight out of your book. So we're just going to go back. Like, forget about limits for a minute. I got to make sure you guys can do some algebra. All right. So write these problems down. Put the video on pause, see if you can bust these out, and I'll walk you through them, all right? Yeah. All right, that should have been time for you guys to write all these all down now. So, let's go over and evaluate A, B, C, D, and E. So, we have A here. Logarithms, remember, what question must we ask ourselves? Okay? 4 to what power equals 64? Well, the answer to that question is 3. Okay, 4 to the third power is going to equal 64. So log base 4 of 64 is 3. Oh, we got a little tricky here, huh? So, sine of 0. Guys, remember the inside part of a trig function is going to be your angle. So this is representing 0 radians. Sine, or the answer of a sine, is going to be the y value on the unit circle. All right, so if we think about this, 0 radians is going to be way over here. Sine is my y value. I'm not going up or down at all. Sine of 0 actually is going to be 0. All right? Let's talk about cosine of pi over 2 now. So remember, this is going to represent my angle. Okay, pi over 2 radians. Cosine represents my x value on the unit circle. So, pi over 2 is going to be up at the tippity-toppity of the circle there. Okay, cosine is the x value. What's the x value up at the tip-top there? Well, I'm not going left or right at all. My x value is a 0. Wow, 2 zeros in a row. Can we go for 3? I don't know. All right, now this natural log of 4, it's a little trickmeister, isn't he? Okay, because we ask ourselves E to what power equals 4, and that's not something our brains can do. We need a calculator to further evaluate that. Okay, so we're just going to leave him right there as natural log of 4. Here we have cosine of 0. 0 radians is what that represents. Cosine is going to be the x value. The x value at 0 radians, well, 0 radians is way over here on the right side. Not the left side, the right side. Okay, my x value at that location is going to be 1. So what we have here is the natural log of 4 times 1, which just is going to be the natural log of 4. All right, moving on to E. Ooh, we have E, and then we start off with an E. What a coincidence. Or was it? All right. So, here we have E to the 0 power. We know that anything to the 0 power is a 1. So, this guy makes a 1. Times, we're going to have sine of pi over 2. I feel like we've done something very similar to this already. Pi over 2 is up at the top. It's our angle. We're at pi over 2 radians. Sine represents my y value. My y value up at the tippity-toppity is going to be 1. So here we have a 1 times a 1, which makes a 1. And that's it. So hopefully this was a good review for you guys. Really, the limits you guys are going to be doing in tonight's homework really aren't that bad. It's not really anything new, but you're going to have to be evaluating some more difficult logarithms, some trig in there. Okay, so you can't freak out. You got to remember how to do all that. I think the last couple problems are going to be graphing ones on your homework tonight. I don't think we need to go over that. I feel like I did that enough with you earlier. Okay, it's going to be the algebra I think you guys are going to struggle a little bit more with, so we're going to focus there. Okay, so we've got some tricky things going on here. So what you guys don't know, but you're gonna need to know, because you might be seeing it on a test, and it might be on like a calculus test next year for most of you. Okay, what you need to know is the limits as x approaches 0 of sine of x over x. Okay? So now, guys, if we were to evaluate this, we'd plug in 0, correct? So what we're going to get here would be sine of 0 divided by 0, all right? So, well, I see my denominator's already no good. We're going to have to finagle or sign analysis. Sine of 0, remember, 0 radians is going to be on the far right. Sine is the y value. That would be 0. Okay, my y value there is 0. This would be 0 over 0. So what we're going to need to do is finagle it, but we don't know any method to finagle this. Okay? Another thing I want to point out, do you notice how I just wrote this directly underneath? I never ever wrote equals. Okay, because this does not equal sine of 0 over 0. It does not equal 0 over 0. Okay, it's going to actually equal the number 1. Now, there's no way for you guys to have known that, other than maybe if you typed it into a calculator. Okay, I'm not even going to try to graph it. I think I know it. Yeah, we'll graph it. What does the graph looks like? Okay, there's going to be a hole at the graph at 1. Okay, it's going to be going off to either side, and it just keeps going back and forth, back and forth, back and forth. That's a pretty sloppy graph, but I just want to give you guys an idea. So if you were to graph it, that's exactly what it's going to look like. Okay, actually remember, when you graph things on your calculator, you're not even going to see that. It's just going to look like it's continuous. It's going to look like the value of that actually is 1. Okay, but there's actually a point disco there because 0 divided by 0. Alright, so it's actually the limits approaching 1, right? Because as you approach from the left, as you approach from the right, the y value gets closer and closer to 1. Alright, that's just something you guys are going to need to know, because now we're going to do some really nasty ones, okay? See how good your algebra really is now, huh? Lots of fun! Here we go. So guys, all you're going to be doing is basically evaluating limits all day today. That's it. Piece of cake. So if I gave you the limits as x approaches 0 of sine cubed of x over x squared. Alright, now, first thing you guys want to do when doing limits is, number 1, direct sub. Okay? Direct sub, if you get a number, we're all good. If our denominator is going to be 0, though, now we're in trouble. All right, that's when you got to finagle or sign analysis. So let's see which one it's going to be. So obviously we've got 0 in our denominator, right? 0 squared is 0. Up on tippity-toppity here, we have really sine of 0. That sounds familiar. Okay, all cubed. Okay, if you guys remember sine of 0, we literally just talked about it. Sine of 0 is a 0. Okay, the y value at 0 is 0. So that was lovely. We got 0 over 0. So we're going to have to finagle it. Now, this isn't going to be where we have to factor. We're just going to kind of split it up a little bit, okay? So, do you understand? I guess I'm going to write an equal sign here. Just, you guys want to be leery of that. Don't be writing equal signs all over the place. Okay, the limit as x approaches 0. Isn't this really going to be sine times sine times sine in the numerator? Sine of x times sine of x times sine of x. Okay? In my denominator, x squared is really just x times x. Okay? So, we have sine times sine times sine divided by x times x. Now guys, remember, if we're just multiplying them, couldn't I even split this up even a little bit more and just add sine of x, okay, times sine of x over x, times sine of x over 1. See how I did that? Because remember, when you're multiplying fractions, you just multiply straight across, on top and on bottom. Okay? So, if you remember, Ryan taught you guys like all the theorems there, like theorem 2, theorem 3, where you can split up your limits. Okay? We're going to split these guys up. You can split up your limits as long as we can split up multiplication and all that. So this is going to be the limits as x approaches 0 of sine of x over x times the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of sine of x over 1, which is really just the sine of x. All right. Now, going back to what we talked about not too long ago, the limit as x approaches 0 of sine of x over x is going to be 1. So, this guy is going to be 1 times this guy is going to be 1 times over here, now you can plug in 0 for x. So this is going to be times sine of 0. Well, sine of 0 is 0 for the 20th time today already. So 1 times 0 is going to give you an answer of 0. Okay? Just one thing about notation. Actually, a couple things about notation. Let's talk about that darn notation, because that's where most of you are going to lose points. I really only wrote one equal sign. Okay? This limit does equal this limit, so it's not that big of a deal. I do have a parenthesis here. It's just kind of hard to see with that. It was there, though. Yeah. Another thing. Okay? Because the biggest one right here is you never want to say equals 0 over 0, because it really doesn't. On the AP Calc exam, you're going to lose a point that you could get if you ever say equals 0 over 0 on this. No matter where you write it, just don't write 0 over 0. Or don't write equals 0 over 0, okay? Other things. I wrote the limits every single time until I did what? Okay, until I did direct sub. Okay, so here I just evaluated this one because I knew it's going to be 1. Okay, but here I wrote this limit every time until I plug 0 in for x. Once I did that, I no longer write the limit. Okay? Let's rock and roll here. I almost fell. Those darn slippers, I tell you. Alright, here we go. I'm going to give you guys another crazy one there. With this darn sine of x over x, we're going to get the limits as x approaches 0 of x plus 3 sine of x over 3x. Okay, I'd like you guys to give this a whirl, see if you can do it on your own. I have my doubts. It's going to be kind of rough. Yeah. You good? All right, here we go. So, let's talk about this one. Let's plug in 0. So when I plug in 0, I'm going to get, my denominator is definitely 0, so that's already not a good thing for us. Can't plug in up top, I get 0 plus 3 sine of 0. And we've discussed this already, sine of 0 equals 0. So this is going to be 0 over 0. Great. I need to finagle this somehow. Normally I'm thinking factoring, right? I got to factor somehow. Maybe GCF. Up top, I have no GCF. Bottom, just 3x. Hey, can I just cancel my 3's? Okay? So this 3 is not being multiplied by everything else on top. You cannot cancel that 3 then. Alright. I give up. What are we going to do? Never give up, alright? Remember, Timmy the Turtle says it's always too soon to quit. So, here we go. I'm going to write my equal sign here one more time. Okay. We get x equals, or as x approaches 0. So guys, what we're going to do is I'm going to split up this fraction. Okay, we want to be very careful about this. Remember, when we split up fractions, I'll try to give you an example over here. Let's say I had 3, let's say x plus 3 all over 2. Okay? Isn't this really going to be equal to x over 2 plus 3 over 2? Okay, because if you're working backwards and want to combine them, we have x over 2 plus 3 over 2, you have to have a common denominator. Well, our common denominator is already there, it's 2. So then all you need to do is add the top, denominator stays the same. Okay? Let's say it was reversed though. Let's say I had 2 over x plus 3. I cannot split that up. Okay? If I were to split that up, this is bad. Okay, I'm going to write this rest in red because it's so bad. 2 over x plus 2 over 3. Okay, understand these are not going to equal each other. You cannot split up your denominator like that. Because now if we want to go backwards and combine them together, we need a common denominator. So I would then need to multiply by 3 over 3, multiply by x over x. So I get 6 over 3x plus 2x over 3x, making 6 plus 2x over 3x. Okay, those are definitely not equal to each other. This was garbage. Okay, so be careful. That's just kind of a common mistake I want to talk to you guys about and warn you. So you can split up a fraction, like if you just have one thing in your denominator there. Okay? You can split up the addition from your numerator because they have a common denominator. So going over here, that's exactly what I'm going to want to do. So I've got x over 3x plus 3 sine of x over 3x. Okay? Guys, I didn't necessarily need parentheses around it here. Okay, but now, do you see how it's separated by an addition? Okay, these are two separate things, so now I have to have parentheses around all of that. So what we're going to do now is split this up because of those, like theorem 2 or something. Or whatever that theorem was. So this is going to be the limit. Remember, we don't care if you guys remember what the theorems are, as long as you remember how to apply them. That's going to be most important. So this is going to be as x approaches 0 of x over 3x plus now the limit as x approaches 0 of 3 sine of x over 3x. Alright, so when I look here, I can now reduce that, right? X divided by 3x, but be careful with this. My x's cancel, but I still had a 1 out in front of that x. So this is going to be limits as x approaches 0 of 1/3. Okay, so that's just going to be a constant. Over here, my 3's. Okay, that 3 on top is being multiplied by everything else on top. That 3 on bottom is being multiplied by everything else on bottom. So, my 3's, I'm left with the limits as x approaches the 0 of sine of x over x. Man, that bugger is coming up a lot today, isn't he? Alright, so here is going to be the limits of a constant is going to be that constant. Okay, so this is just going to be 1/3. I was trying to say it all fancy or something. I don't know where I was going with that. Over here, guys, remember limit as x approaches 0 of sine of x over x is going to be a 1. Number 1. So, I'd like you to combine these one last step here. So, we would need a common denominator. 1 was really 1 divided by 1. Multiplies that by 3 over 3. Remember the funny form of 1. So we really get 1/3 plus 3 thirds is going to make 4 turds. And there you have it, guys. That'll be your answer. Alright, holy cow, we're already at 20 minutes. Wow, time flies when you're having fun, guys. We're going to do some, I guess some very similar to your homework practice now. Actually, these were pretty similar to your homework practice too. We're going to do like number 8, 10, 14, and one other one I can't remember the number of right now. But we're going to start with number 8. So guys, in your homework, you're really doing the odd numbers. This is an even number. That's going to be very, very similar to your homework. Spooky. Alright. I'm just going to write these down, guys. I would go ahead and write all of them down as well. Okay? If I finish writing them down before you, maybe put it on pause, see if you can work through these problems yourself, alright? There's our first one. We'll do number 10 as well. I'm just writing these exactly how they look in your book. Okay? I always hate not having parentheses around stuff. At least with limits. It's kind of the same way with trig. I always like to have like sign and then parenthesis, natural log, and then parenthesis. I'm the same way with limits. It's technically correct here because it's not split up. Like this fraction bar is grouping it together, so that's fine. Okay, here it's all being grouped inside that natural log. Okay, so you guys, whatever kind of floats your goat here, I'm just trying to write it exactly like they are in the book. Pretty much from here on out, I'm just going to write them with the parentheses because it makes me happy. And I'm going to do what makes me happy. So we've got x cubed here, minus 2x squared, plus x minus 2, all divided by x minus 2. That one looks fun. I was supposed to do another one, but I made up my own because that's always fun to do too. Oh, I made this up. I'm going to put my parentheses in there because it makes me happy. I've got sunshine on a cloudy day when it's cold outside. I've got the month of May. I guess, sing along. You'd say, oh, what can make me feel that way? My girl, my girl, my girl. Alright. Hopefully you guys paused it, got this all done, worked through the problems. Okay, I'm going to walk you through them all now. It'll be fun times. So remember, the first thing you always want to do is try direct sub, plug stuff in. So here I'm going to get the natural log of sine of pi. Okay. Well, I lost my over 2. So this is going to be pi over 2. I know something didn't seem right there. That seemed kind of fishy. So sine of pi over 2. Pi over 2 is up at the top. Sine, remember, represents my y value. My y value up at pi over 2 is going to be 1. So this makes the natural log of 1. So guys, remember, what question are we asking ourselves here? Okay, here my base is e, right? Natural log is log base e. So e to what power is going to equal 1? Well, really, anything to the 0 power will always equal 1. Didn't really matter what our base was. Log of 1, no matter what your base is, will always be 0. Okay? So our answer was 0 there. Direct sub worked. It looked kind of scary. Just got to have faith. You got to have faith. I don't know the rest of that. Here we got some direct sub again. Okay, I'm just going to plug in a for x. Okay, this is going to be a squared minus 1 over a squared plus 1. Now, I know it's going to freak a lot of you guys out because we got variables in there, but I guess this variable is more like a constant because x is approaching a constant. Remember, it's like x approach the constant c. Okay, this is just a different one. A, it's not a big deal. You can stop there. Okay, that bottom doesn't factor, nothing cancels. Right, those a squareds do not cancel because the a squared is not being multiplied by everything else on top. That a squared is not being multiplied by everything else on bottom. So that'll just be our answer right there. I do like it if you circle your answers or box them in some way. Warms my heart. Oof, look at this guy. So we're going to plug in a 2, right? Direct sub. Okay, if we can direct sub, life is good. So I got, well, I'm just going to look at this denominator right off the bat, okay? 2 minus 2, it's no good. We're dividing by 0. Okay, so just make sure you definitely don't say equals here. Now, remember, if I get a number on top, it's going to be sign analysis. If I get 0 over 0, we're going to need to finagle in some way. Guys, these are the same steps you're going to follow every single time. Direct sub, 0 over 0 finagle, number over 0 sign analysis. Okay? So I'm going to plug in 2 here. 2 cubed is going to be 8. 2 squared is 4 times negative 2. That makes a negative 8. So those guys are going to cancel. Then I've got a plus 2 minus 2. Okay, now it looks terrible. I got to extend that fraction bar. Hopefully you guys realize we're going to get 0 over 0. Don't say this equals 0 over 0. Okay, it doesn't. Well, it's just going to be 0 over 0. Okay, that tells us what we're going to need to do now is finagle it in some way. So guys, my first, well, I've done enough of these, I know what to do, but the first thing I always look for is going to be to factor. Okay, can we factor this? Well, the bottom doesn't factor anymore. We really want that x minus 2 to cancel. We got 0 over 0. If all else fails, guys, you should be able to do synthetic division with the top. Okay? Like if you set this up, you should be able to do it with a 2. And then 1, negative 2, 1, negative 2. All right, run through sign analysis. You're going to get 0 at the end. Life will be good. Okay? However, it'd be even better if you recognize that this is 4 terms, no GCF, so what we're going to do is do factor by grouping. Okay? So, it's been a while. I'm just going to write my equals again. We're going to get the limits as x approaches 2. Okay, so when I do my factor by grouping, okay, remember I'm going to kind of group my first 2 together and take out a GCF here. Okay, my GCF of my first 2 terms is x squared. What I'm left with then is x minus 2. All right, now I'm going to do a GCF again with my last 2 terms. So, there's really nothing I can take out. All right, remember the other part of factor by grouping. I factored out my GCF, I was left with an x minus 2. I better be left with an x minus 2 over here, otherwise factored by grouping is not going to work. Okay? Well, I am left with x minus 2. It's kind of like I'd be factoring out a 1. Okay, I'm not really taking anything out of it, it's just x minus 2. Okay, but that 1's going to be very important to us. All divided by x minus 2. All right, so now it's almost like we're going to do GCF again with our top. Okay, we've got like 1 term, we've got like 2 terms. What do they have in common? Well, they got an x minus 2 in common, so that's what we're going to take out. So now I've got the limits. Okay, I'm going to take out x minus 2, all of it. What I'm going to be left with would be an x squared and a plus 1. So that needs to be in parentheses, guys. That plus 1, like I said, is very, very important. All over x minus 2. Don't forget, this is as x approaches 2. All right, so now my x minus 2's cancel because this x minus 2 is being multiplied by everything else on top. This x minus 2 is really being multiplied by 1 on bottom, so bam, bam. All right, so now I have the limits as x approaches 2. Of x squared plus 1. Okay? Now, direct sub is going to work. So guys, once you cancel that problem factor, okay, direct sub will work. Once we do direct sub, now that's when you can quit writing limits every time. So I plug in a 2, I get 2 squared plus 1. This is 4 plus 1, making 5. Piece of cake. Sweet. Anything else I want to talk about on that? Alright, let's talk about parentheses because I'm really kind of a pain in the butt about parentheses. You guys know that. Okay, this is how the problem was written. I did not need parentheses here because this fraction bar grouped it all together. Okay? Here, my fraction bar is still grouping it all together. Didn't really need these outside parentheses. Same thing for here. We didn't really need them. Here though, okay, we got it separated by addition. There's no fraction bar kind of holding them together anymore. Okay, so that is when you would definitely need some parentheses. All right. Oh, that was fun. Last one here. I'm going to plug in a -4. Okay, when I plug in -4, I'm just going to plug it in the denominator first. See what I'm kind of dealing with here. So 2 times -4 is going to be -8 plus 8. So in fact, my denominator is going to be 0, which is bad news bears. Okay, I plug in -4 up here. -4 cubed. -4 times -4 times -4. So that's going to be a negative. 4 cubed is going to be 64. So we got -64 plus 64. What happens? We get 0 over 0. All right, so we're going to need to finagle it. How are we going to finagle it, though? Well, more times than not, guys, like I said, you're going to be ending up factoring it. Okay, so we're going to factor this guy. Hopefully you recognize we have a GCF in our denominator. The numerator, though, you got 2 terms, no GCF. Okay, 2 terms, your options are really either difference of squares or sum and difference of cubes. Okay? Difference of squares does not work because difference of squares has to have a negative here. Sum and difference of cubes, it's sum or difference of cubes, really. So it can go either way. Okay? I'm just going to rewrite this. I'm going to get the limits as x approaches -4. Okay? I'm going to write this as something cubed, which is going to be x all cubed plus, I'm going to write it as 4 all cubed divided by, take out my GCF, 2. I'm left with an x plus 4. Okay? So now we can do our factoring by sum difference of cubes. Technically it's going to be sum of cubes here because it was a plus in between. So, we've got the limits. As x approaches -4. Ugh. All right, so guys, remember, sum of difference of cubes is going to be 2 terms times 3 terms. 2 terms times 3 terms. Okay? I always say I bring the first one down. The last one just comes down. Those are going to match up. The first one over here is going to be my first term squared. So when I say the first term, I'm referring to x. X squared is just, well, x squared. My last one is going to be my last one squared. 4 squared is 16. The middle is the first times the last, making 4x. Okay? My denominator is still 2 times x plus 4. Now you guys all say it with me, all right? You ready? The first one stays the same. The second one switches. And the last one's always a plus. Now you guys better be nice and loud so we don't have to do it again. All right, so here my x plus 4 is now being multiplied by everything else. That cancels with my denominator, where my x plus 4 is being multiplied by everything else in the denominator. Now, that was my problem factor. We should be able to do some direct sum. Okay, let's give it a whirl. So when I plug this in, I'm going to get -4 squared minus 4 times -4 plus 16. Don't forget that you're dividing it all by 2. Okay. Negative 4 squared is 16. Negative 4 times negative 4 is negative 4 squared, which is 16. And we have 16. So this is 16 plus 16 plus 16, which makes 48, divided by 2, giving us 24 hours in a day. Alright, I think you guys had enough of this. I did have one more, but I think you guys are good. You got the gist of it. Alright, good luck. See y'all tomorrow.